I had no idea that this was even capable. What you guys do?
Wherever you have two powder particles next to one another, they actually diffusion bond together. So it's actually a diffusion bonding process.
I feel like we can usually look at a part within 5 minutes, just scanning the print and the requirements and know right away whether or not it's going to be a good fit.
And there's nobody else in Minnesota that does this, right?
Correct.
Established a framework of values for your organization. Get back to those values and reinforce those values and live by those values.
Listen up, America. This is the American Made Podcast, the show that highlights America's business leaders and experts in all aspects of the manufacturing industry. If it's made in America, you'll find it here.
China. Made in America. Products made with American heart, American sweat.
Now, your host of the American Made Podcast, Jason J. Webb.
What's up, America? It's Jason Webb, and I got something sweet for you. This is going to be sweet, let me tell you. In front of me, I got the president of FMS Corporation, based out of Bloomington, Minneapolis. Go Bloomington. And the CEO, President, Mr. John F. Sweet. How you doing, John?
Doing great, thanks.
Yeah, that's a pretty sweet name, man.
I'll cut it out.
And to John's right, I got Ryan Gebauer. How you doing, Ryan?
I'm doing well, thanks, Jason.
Good. And you are the product development engineer for FMS. Yeah?
Yep, that is correct.
All right. So I've already been enlightened about this area of manufacturing. I had no idea that this was even capable, what you guys do, right? So my simple mind has this image of powdered metal going into a form, the form then getting heated, and then that powdered metal becomes solid, and you have this very precise part. So other ways of achieving these similar end result would be machining, where you're taking material away from, let's say, a block of metal, and then maybe you got this sprocket or whatever it is that your end product is, or I don't know, foundry casting type work, like the old school molten metal poured into a form, and out comes a metal product of a certain shape. But you guys do something that I've never heard of. Now, did I totally screw that up? I mean, let me pass this over to Ryan. Ryan, explain what it is that you guys do.
Sure. So we start with like a highly engineered metal powder. We don't actually produce the powders in-house. We purchase them from various vendors here in the United States. And we put that powder into a metal mold, and we compact it at really high pressure, somewhere in the neighborhood of 40 to 50 tons per square inch. And then we eject that compact out of the mold. And at that stage, it's strong enough to be held together, and you can handle it. But it has no functional strength. And then
So at this point, it's like powdered metal that's packed together like a snowball.
Yeah, if you can imagine like the same process that like Tylenol and other over-the-counter pills are made, it's very similar to that.
Okay.
But with metal instead.
Okay, so pop it out of the mold, and then what?
And then we place it on a sintering furnace, which is really just like a long continuous belt that runs through temperatures of up to 2100 degrees. And then it either gets rapidly cooled or slow cooled, depending on the material, as it comes out of the furnace. And once that process is complete, it's essentially as hard as any other, metal part that you'd make via casting or forging or machining.
Did he get that right, John?
I think he did.
Yeah.
Close
Yep,
enough.
close enough. All those little powder particles, wherever you have two powder particles next to one another, they actually diffusion bond together. So it's actually a diffusion bonding process to make the kind of the solid material.
Okay.
So, but we manufacture components that are really high in strength. I mean, there's we were just talking before we went on air about a sprocket that we do for somebody who makes ATVs locally here, and very highly stressed component that drives the rear wheels of an ATV, and that's a powder metal component. So high strength.
Yeah. So once it's cooled, is that the finished product, or you got to buff it or shine it up or file it a little bit?
There's a lot of post-processing operations that you could do that would be similar to other manufacturing methods, plating, tumbling. I'm trying to think of. You could heat treat it if you wanted to change the properties even further. There's some materials that would get like a secondary heat treatment. But I'd say most commonly plating, just from a corrosion resistance standpoint, is usually the most frequently used secondary process.
So right out of high school, I went to a 2-year tech program down in Hutchinson, something called non-destructive testing. And part of their curriculum, I had to take some metallurgy classes.
Yeah.
Right? And
Just enough to be dangerous?
Yeah, well, not even that. But it was interesting. I mean, when you're talking your metal talk, I'm having flashbacks from I don't know how long it's been, 20-ish years, 25 years ago. It was interesting. We also had to learn how to weld, which I enjoyed, by the way. Yeah. All right. So FMS, what's that stand for?
Well, that's my grandfather's initials. Our founder, Fred Martin Sweet.
Okay.
And he founded the company way back in 1946. So we're just a little over 75 years old.
Wow.
As a company right here in the Twin Cities.
Yeah. And I think you said your dad and your uncle also work for the company. So you are third generation along with a couple brothers?
Yep. Got two brothers involved in the business, and we do have a fourth generation that's coming up as well. So
child of yours or
child of mine? I have a son who's in our quality department right now, and kind of learning the business, and I think he's got a liking to it. So we're hopeful.
How old is he?
He is. Let me think. He's 25.
25.
Yeah.
So growing up, John, did you always know you're going to be part of the family business, or did you go out and try to do something else?
My dad never really pressured us to come into the business. He always kind of just held it with an open hand. And I did. I started out in aerospace engineering. Was going to go into being an aerospace engineer be an astronaut or something like that. But about halfway through my college career, I kind of woke up and, this might not be too bad to be involved in the family business. So at that point, I actually switched schools out to Drexel University in Philadelphia and finished my school career out there, and then came back and joined the business.
Why Philadelphia?
It was and is one of the schools in the country that specializes in powder metallurgy. There's not too many in the country. There's maybe about a dozen schools that really have a strong program in powder metallurgy. And there's a particular, there's our particular classes that are really important to that, our discipline. So
yeah,
that was the closest one to well, I guess it wasn't the closest, but they had some interesting things. They had a co-op program. And
so what was your degree in that you left there with?
Materials engineering, actually.
Materials engineering.
Yeah.
Interesting.
Yep.
How long you been in the boss's chair here, president and CEO?
Well, I think my dad retired in 1998, and so I became the president that year. And so yeah, it's coming up on let's see, over
25 years.
Yeah, 20 plus. Yeah, I've been with the company since 1990. So
Wow.
worked quite a few years before my dad retired.
Gotcha.
So, yeah.
Okay. So Ryan, can you give me an example of a product you recently worked on or are working on without letting the cat out of the bag? You know, it's, I don't want you to give away any secrets, but just to give the listeners an idea of how maybe this type of manufacturing process could be applied.
Sure. The most common thing we work on is gears. We make a lot of gears for power transmission, for industrial equipment, for ATVs, snowmobiles. We also make a lot of CVT components for those same customers.
CVT?
Continuously variable transmission.
Oh, okay.
So like you would find in an ATV or a snowmobile, without saying any names.
Gotcha.
It's probably the highest volume really components we produce are go into ATVs. As far as recent projects are concerned, one that doesn't pertain to the power sports industry, there's a really good one. A customer approached us who had worked with us maybe 20 years ago, no longer lives in Minnesota, but had moved out west. And he owns a company that cleans windows or that cleans mirrors for a solar field, concentrated solar. And they were having issues with these mirrors failing, falling apart. And he reached out to us with an idea, because he's sort of a serial entrepreneur type, to replace or repair what was already designed in by the manufacturer. And we made him 5,000 of these components. So you think of them kind of as like a fastener or a washer of sorts that help hold an assembly together. But when he approached us, he basically told us that he didn't feel like there was any other way to make the part except for using the powdered metal process because of his familiarity with it, using it in the past. And so we made 5,000 samples, and we shipped those out to California, and they've been installed on these concentrated solar field mirrors, and we're just waiting to hear back now he needs approval from the power company, whoever built the solar, Google is involved. There's just a lot of hands in the pot. So once he gets the approval, we should hopefully be making, 800,000 of them over the next 5 years.
How many?
800,000.
Dang.
And it was really an excellent application of the technology, because it's a high strength material. It is high precision, and then it's got a 3-dimensional shape to it. So it's got a radius on one side, and you really couldn't manufacture this component with casting. You couldn't machine it for a reasonable cost, and in general, that's the way that most of our applications are. That you can't really manufacture those components in an efficient way by any other process.
What's the official technical name for your process?
It's just press and sinter powder metallurgy.
Press and center powder metallurgy?
Powder metallurgy, yep.
Okay. So if somebody wants a part made, is it difficult to determine, like, all right, should I use this method, this press and center powder metallurgy, or should I use machining, or should I use casting? Is deciding on the best process relatively easy, or not necessarily?
I feel like we can usually look at a part within 5 minutes, just scanning the print and the requirements, and know right away whether or not it's going to be a good fit.
Yeah. Okay.
Whether that's a good fit for the powdered metal process in general or a good fit for us, that decision usually just takes like 5 minutes of staring at the CAD model, or a print.
Yeah. Usually the characteristics, it's got to be usually higher volume, let's say 10,000 parts annually or more.
Okay.
Most of our components are in the 10 to 100,000 annual components. But a million, it's the process is capable of doing millions, but high strength again, and a three-dimensional shape of some sort that's not easily machined. Those are usually the best fit.
All right. Do you have customers sometimes that are like, hey, I've been making this part via machining and I want to check out to see if it's more efficient to have it done this way? Is that
All the time.
a conversation?
All the time. That's usually typically what we're looking for is, like yourself, there's not very many people. I didn't even know what powder metal was when I started at FMS 7 years ago. So they don't really teach it in schools except for a handful of colleges. If they did when I was in school, it was like half a day, like a blip on the radar of a whole semester. And so there's not a whole lot of people that are really familiar with the process at all. And so a lot of what we end up doing is prospecting, trying to find people that aren't familiar with the process and teaching them about it so that they can better understand what else is out there. Different way to make it.
Do you have any success stories? And I've seen your website here. One thing that's cool about this is the history, but applications under that it says case studies, right? Mm-hmm. Does anything come to mind where, I don't know, Joe comes in and says, I've been making 1 million of these every year via machining or casting, and I want to check it out, see what you guys can do. And you end up not only producing a better part, but saving them money?
Yeah.
That's a common scenario?
Yep.
Yeah.
That's, I think, a lot of the clutch or CVT business that we do started out that way. The customer was machining parts out of billet, and we approached them with an idea, or they approached us because they had heard of what we were capable of, and we pivoted, and now we make basically every clutch weight that goes into their brand of CVT.
And there's nobody else in Minnesota that does this, right?
Correct.
Yeah. All right, so let's go into the history a little bit. So it started back in 46 by your grandfather, right, John?
Yes. Fred Sweet.
And did he start doing the powdered metal thing right away?
He did not, but he was actually a sign maker before World War II. And so he would bend neon tubing to, form a sign. And then he got transferred out to the West Coast during the war to support the war effort. And while he was out there, he observed this really strange new process, powder metal process, that was actually being used to make bearings and oil light bearings, which maybe some of your listeners know about, are still manufactured via the powder metal process. And so they actually take a powder metal bronze and make a bearing out of it, and then fuse that with oil, or impregnate that with oil.
Okay.
But so those are still manufactured. But anyway, he then through business relationships with other companies in the Twin Cities area, mainly Honeywell and 3M and companies like that, several other armament manufacturers also, he began to do some contract manufacturing for these other companies, and it really caught on and started to grow a great deal, and actually then became its own entity within the FMS Corporation. We still manufactured the sign products for quite a number of years, but now that side of the business has been spun off, and there isn't a great deal of neon actually done today. It's kind of more of a boutique, type of endeavor. But the powder metal side has continued to grow. The powder metal materials or components are used. One of the biggest markets for the powder metal industry is the automotive industry. So automobiles manufactured here in the United States, there's an average of around 55 pounds of powdered metal parts in every car. So that's something that we support the automotive industry quite a bit, and there's a number of FMS components in the cars that we drive.
Cool. How many employees are you at?
We're at around 100.
100? Yeah.
Yep.
Okay, so it started in 46 and 84. It says you guys moved to Bloomington. Where were you?
64, actually.
yeah.
Yeah, we moved out to 86th and Harriet Avenue.
Hmm.
And so at the time, there was just nothing but farmers' fields about as far as the eye could see back in the 60s in Bloomington.
Right.
And David Fong's, of course.
Yeah.
And what?
David Fong's,
David
the
Fong's,
Chinese
yeah.
restaurant.
Oh.
They were started in
Is that
1958.
still there?
No, they just closed down this last year.
Okay. So 1970, 3M is the first large OEM customer.
Yep. They were making copy machines really to sell the paper. And there's a lot of little gears and other components inside a copy machine that are metal components.
Okay.
And so we started making gears for 3M's copy machine business.
That's a good account.
Yep.
It grew quite a bit from 1980 to 2010.
Yep. We, really that was the era where the signed product side of the business, started to wane with the advent of LED technology, kind of took over that industry. And, but the powder metal side continued to grow. And, a lot of those customers that we took on in that era we're still doing business with today. So
Good. Reinvested a bunch of money, 2017 to 2023, and looks like a bunch of equipment, huh?
Yep, these presses that we use to make the components, they're not inexpensive. So in the millions of dollars each.
Wow.
In order to have a press that can compact a material, let's say with 200 tons of force and position those rams to within a 10,000th of an inch on every stroke requires a lot of technology. And so, and you pay for that technology. So we did have to do a lot of investment in the business, but we're in a good spot today.
Good. Present day, third generation, talked about a fourth generation. Your son's working his way up the ranks, and lots of growth.
Yeah.
Guys are killing it.
Yeah.
Well, that's cool.
Business is good. The powder metal process is for the right type of component. It's an excellent way to manufacture high volumes of very precise components, metal components.
Yeah.
And a lot of our customers have come to that realization.
Ryan, how'd you get in this position as being the product development engineer for FMS? Well, first of all, where are you from?
I'm from Indiana originally.
Indiana.
Yep.
Yeah?
Indianapolis area. Grew up there.
What brought you here?
My wife.
Is she from Minnesota?
Nope. She's from Indiana also, but we lived in Milwaukee for 5 years after college because she got a job with Kohl's Corporation, and then of course, Target is a kind of a competitor of Kohl's. They were courting a bunch of people from Kohl's, and she just keeps getting me to move further and further away.
Okay. So how long have you been in Minnesota?
Since 2017.
2017. And when you were in Indiana, did you go to college or no?
Yep. Yeah, I went to Purdue University, mechanical engineering.
Oh, smarty pants.
No. To be honest with you, I had a real focus when I was in school on, I was part of the American Foundry Society, Purdue chapter, and my roommate was also. And when we were sophomores, everybody had graduated. We were the only two people left in the entire club.
Oh, it wasn't too popular.
No, it was not. As you can imagine, the foundry industry is not that exciting, but it is for the right people. And so we were tasked with just kind of growing that club. It looked good as a resume builder. And, but that got me really into the foundry industry. And one of the things you notice when you walk around, especially foundries, is that you see a lot of people with gray hair. So it seems like a great opportunity as a young college graduate to come in, learn from people who have been doing it for their whole life. And when they retire, hopefully move into their position. So it was more a strategic thing, I think, on my end. But I started out like thinking that I was going to be in the foundry industry my whole life.
Yeah. I know a guy that's doing just that. He flies all over the country, looks at foundries, and he's been buying them left and right because, like you said, it seems like an industry in which a lot of the people that work in it are getting older and I'm not sure what to do. So I don't know. He's got his own processes and systems as far as evaluating if he should buy them or not, and then once he buys them, makes them more efficient.
Yeah,
You know, so that's cool.
yeah. And actually, so when I moved to Minnesota, we're right next door, as you can imagine, to a foundry. And I didn't even know that FMS existed. I was interviewing at the foundry next door. When I left there, I didn't really like what I had seen at the time. They didn't really have an engineering role. It was more of like a sales, strictly like an account manager type role. And so I drove up and down the little business park that we're in, and I wrote down the names of all the companies, and I thought, well, let's see what all these people do. And it just so happened that FMS had a job posting for exactly what I was doing in my current role. So
what was that?
I was cost estimating, like kind of like think of it more of like sales engineering, applications engineering type role that I was doing at the foundry before, where a customer comes to you with an idea, and then you try and turn that idea into a reality at the cheapest cost possible by solving whatever problem that they've got.
Yeah.
And it just seemed like a good fit. I called HR the moment I saw the thing, and they had me in for an interview the next day. At that point, I was, I had moved here. My wife had a job, but just completely unemployed with no idea what I was going to do.
Yeah. Did John interview you?
He did, yeah. 5 people. He had 5 people
Apply for the position?
No, 5 people interview me all.
Oh.
All at once.
At one time?
Yeah.
So you had you in the hot seat.
That's like 5% of the whole company right there.
At the time.
Peppering him with questions.
Yeah,
Peppering him.
Yeah.
He handled it very well.
It was good.
So
Yeah. Well, good. So what city do you live in now?
I live in Richfield now.
Richfield?
Yep.
And got a wife, you said? She's still with like Kohl's Target?
She works with Target, yeah.
Yeah. Any kids?
I have one kid, Miles, he's 3, and then another one on the way.
Oh, another one.
boy.
Oh,
Yeah.
Congratulations.
Thank you.
Miles, huh?
Yeah.
Sweet.
It's nervous,
Yeah.
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 We don't have any family around, so,
Yeah. You're
we're
on
about
your
to
own.
be equally numbered.
Yeah. Right. I have 2 boys. They're real close in age, 13 months apart. And when they were both in diapers, bro, that was difficult. Yeah. But as they get older, the more and more fun they are.
Yeah.
They're 10 and 11 now. And, playing football. And it's like, I'm having a lot more fun with them, because they're a lot more able and independent. So got some things to look forward to.
Yeah.
Yeah.
you might even be able to work with one of them one day.
Yeah.
That's right.
Yeah.
Sometimes that happens.
Yeah. So you got a name picked out for the second one?
No, not yet.
No. All right.
Yeah.
John, did you grew up here because your dad was working here, right? Where'd you go to high school?
I went to high school in Burnsville, just
Burnsville?
across the river.
Yeah.
Yep.
And then you went to college out in Philadelphia.
Yep.
And you came back here and started working in the family business.
Yep.
And you're married?
Yep.
Yep.
Married with 3 kids.
Yep.
Luke actually, the one who works with me, is actually my youngest, and then I have 2 daughters.
Daughters are like, no, I'll pass on this whole powdered metal thing.
They just happen to be interested in different things. One is a physician, actually just graduated from medical school, is in her residency right now.
Nice.
And then one is out in New York City, working in the design, actually for a lighting company out there. So she loves it.
Yeah.
I don't know that she'll ever move back to the Twin Cities. I don't know.
So being in the position of leadership, John, being the president and CEO, what do you think makes for a good leader? Just curious. What qualities, or do you have any techniques or things you tried in the past that didn't work and now you do it this way? Any feedback on being a good leader?
Well, I think that one thing that we have done as a company is really established a framework of values for your organization, and to try at every turn to get back to those values and reinforce those values and live by those values. And I think that has really helped our company to just really establish a mode of behavior at the company where we can weed out those people that don't fit with our values and affirm those people that really do fit with our values. And I think it's worked well for our organization. I think we have a very cohesive group of leadership, and I think we support one another and just like to work together. We have a annual leadership retreat that we do in January. Actually, this year we're going to move it up and do it in December. I think try to get that done before the end of the year, and take a fresh look at the. We have 10 company values that we have established, 3 core values, and then some other values that we're working on. And I think that's always our retreat time is always a real rejuvenating time, a time once a year to take a look back and see how we've lived up to what we say is important to our company.
Yeah, that's a good idea. I think that's pretty rare that companies actually take out the time to do something like that.
It's one thing I think that, being a family-owned business, a little bit of a smaller company, we can, I think there's advantages to, there's plenty of disadvantages being small, but there are a lot of advantages, I think, to being small from the standpoint of being able to establish the way that we operate as a business.
Say about 100 employees?
Mm-hmm.
At what point do you think you're not small anymore?
Well, that's a good question. I think we like to in our current size. Actually, I think it references this maybe on our website, but we feel like we're small enough to be custom and to operate like a small business, but we're large enough to still have the engineering expertise, quality systems, all of those sorts of things that our customers can take advantage of. So I guess we're kind of medium. We're between small
mid-size.
and large, but
yeah,
when you're a manufacturing business like ours, once you're up in the $50 million revenue and above, that's getting to be a larger company.
Yeah.
I think we're still in that small range that we can actually stay really nimble and really give very good customer service to our customers.
So what employee size were you at when you started as president and CEO 25 years ago? Do you remember?
I think we were at about somewhere around 25.
25.
Yeah. Somewhere in that ballpark.
So you've grown quite a bit since then.
Mm-hmm. Yeah.
What do you contribute that to?
Well, I think for one thing, certainly the people that we've developed into this leadership team and actually all of our employees all the way down. I think we do have a company culture that is very eager to satisfy the customer. So that's number one, but I think also that we have this technology with the powder metal technology that just was waiting to be used by a number of customers, especially in the 5-state area, but nationally too, but primarily the 5-state area, and we've just penetrated more into the other manufacturers here in the 5-state area, and so just by virtue of continuing to hammer home the benefits of powder metallurgy, I think that we've gained a lot more business.
Do you think there's a lot of growth opportunity left, let's say, in the 5-state area? And okay, so are most of your clients in the 5-state area, or are they kind of all over?
They're kind of all over, but I would say the majority are 5-state.
And is there still a lot of growth opportunity in that 5-state area? And I'm thinking in particular, like these, I don't know, people that are using old school casting or machining, that they're just not aware of the benefits of powdered metal. Are there still a lot of those people out there? Or would you say most people that are participating in the machining and casting, they're aware of powdered metal, but they just choose to go the other way?
I think there's still a great deal of growth to be had, and I'm always surprised that still these things take such a long time to change over time. But I'm still running into people that have graduated from engineering programs, and really there hasn't been much time spent on powder metallurgy in the training.
And there's a lot of time spent in, let's say, machining.
Sure.
Yeah.
Casting
And machining. They spend a lot of time there.
Sure.
But not in powdered metal.
Right.
Need some lobbyists.
Yeah, I know. That's true. I it's always a surprise that, the technology has been around for, 100 years, actually even longer than that, but been accepted in manufacturing process for 100 years, but yet there still isn't much time spent on it in most engineering programs.
So I can think of a company that makes gears for mountain bikes, right? And I know that they're using machining. And are there any types of industry out there in which you could say, hey, if you're making this, you need to check out powdered metal and compare that to your current machining or casting process? Anything jump to mind?
Gears in general.
Any kind of gear.
Yeah. As long as it's, below, let's say 7-8 inches in diameter.
So if you are making any kind of gear that is less than 8 inches in diameter and you're not using powdered metal technology, you need to take a look at it.
Yeah.
Yep.
Yeah.
Another thing that's kind of up and coming would also be like electric motors. The powder metal technology is starting to advance more into the electric motor sector for an electric vehicle, because you can imagine all those parts John talked about earlier, the 50 pounds per North American vehicle that are currently using PM. Once everything transitions over to the electric vehicle market, most of those gears are going to go away, or the connecting rods, all the
Anything that's in the internal combustion engine, there's a lot of powder metal parts in the engine.
And so as things transition to electric motors, the powder metal industry is also trying to transition into the electric motor space. And there's a certain type of material and process that could be used to specifically in like axial flux motor design. Mm-hmm. And so it's the PM process has a pretty good advantage from a torque density ratio when it comes to that particular motor design. And it's just a matter of time, I think, before more companies start to adopt it, because right now it's really expensive.
So if I get Elon on the podcast,
there you go.
I should hook you guys up.
He needs to think about it. Yep.
Yeah.
Well, like companies, there's like Mercedes-Benz just bought Yasa Motors, and that's an axial flux motor design. And up until this point, really, the only people that were using it were the high-end sports cars, Koenigsegg, Mercedes, Ferrari. And so as that technology works its way down in price, just through higher adoption, greater volumes, and things like that, I think that's kind of the next realm of where a lot of powder metal companies are trying to get into that space, is the electric motor space. Mm-hmm. So we've been looking at prospecting with electric bike companies, like recreational vehicle manufacturers, Polaris, Arctic Cat, anybody that's looking to create some kind of electric motored vehicle. We think there's an opportunity there.
Cool. Mm-hmm. My 10-year-old saved up his money over this last 6 months or so from birthdays and Christmases and chores, and he is determined he's going to get this electric scooter called the Pegasus. Dang thing's $1,300. It's on sale for $1,000, and he wants Dad to cover the gap,
Yeah.
And But the Pegasus, the one they had on display, they have this little, so you got the scooter arm, right? And there's this little hinge down here that allows the arm to fold down. Well, there's a little clip that keeps that arm upright, and that clip on the display model broke. It was broken, so he couldn't test drive it. And, and we pray at night, right? We say the Lord's Prayer, and I'm always like, well, is there anything else you want to say before we say amen? In the last couple nights, Jax has said, yeah, God, please let that part come in for that scooter so I can test drive it. Yeah. But those darn scooter goes 30 miles an hour, and there's another one in the shop that goes 68 miles an hour. A scooter. Like,
Wow.
yikes.
Take it on 494.
Yeah.
Yeah. Can you imagine seeing a dude going 60 on the scooter down the road? Yeah, it's amazing what those things can do. All right. So what, before we wrap it up here, is there anything else we need to touch on that we didn't already mention? I don't want to leave you hanging. Or did we nail it all?
Well, pretty much. I think that manufacturing is alive and well in the United States today.
Yeah, buddy.
And I'm grateful for that.
Yeah.
And I think that the manufacturing industry in general continues to advance and to I guess today I can understand somebody young person coming out of college or trade school and what or actually deciding what major they were gonna major in. Where should I go? Well,
Yeah.
I just want to be I want to let everybody know that there's a lot of opportunities in the manufacturing field in the United States, and a lot of high technology, and it's a great line of work.
Good. Yeah. Thanks for that. All right, listeners, if you are in the electric motor space, or you're making gears using old school machining and casting, you got to check these guys out. FMScorporation.com. FMScorporation.com. And we reach out to John Sweet or Ryan Gebauer if you have any questions. That should be it. Thanks
Right
for
on.
listening, guys.
All right, thanks,
for having us,
Jason,
Jason.
for having us.
Thank you.
Thanks for listening to the American Made Podcast. Want to be a guest on American Made or know someone who should be? Apply online at theamericanmadepodcast.com. Don't forget to like and subscribe on your favorite podcast app to be notified when new episodes become available. And we'll see you next time on American Made.